Hello, my name is Nurlina Alisha binti Zaini. My ID number is AB19320, and I would like to start our presentation about flow measurement in detail about flow nozzle. So let's begin. So I would like to start this presentation with an introduction of flow measurement. As you can see in the screen, there is a few important things that we have highlighted about flow measurement. So in flow measurement, the terms of pipe flow rate is used to refer to flow rate for any closed conducate flow under pressure. The closed conducate may be in the form of square or even rectangular, such as a heating ducate, that usually be found in the form of circular. Other than that, major category of flow is open channel flow, which occur when there is a liquid surface open to atmospheric pressure. Measurement of the flow rate of a fluid flowing under pressure is calculated for a variety of purposes, such as billing for water supplies to home or even business, or for monitoring or process control of a wide variety of industrial processes which involve flowing fluid. Pipe flow measurement. Other than that, pipe flow measurement also done with a different pressure flow meter like orific flow nozzle and ventrimeter. Flow nozzle are what we are going to present to you guys today. So flow measurement objective can be divided into three, which is the first one is to calculate the output of instrument, and the second one is to control the direction of the characteristic of a fluid flow. The third one is to measure the volume or even mass of a gas or liquid. The fourth one is to investigate the flow restrict of some type in the pipe and ducate carrying the fluid. The fifth one is to measure the pressure drop, and the last one is to correlate with the flow rate. So in this slide, I would like to tell you more about flow nozzle. So flow nozzle is a device that used to measure the flow rate of fluid in a pipe or conduit. A flow nozzle consists of a cone shape of passage that create a particle blockage of conduit. A flow rate is determined by measuring the fluid pressure before and after the flow nozzle. Flow nozzle also are used to gather data. Other than that, it was used to process improvement in manufacturing performance and tolerance to extreme in process. They offer advantage over orific plates in that they require less upstream piping and incur lower permanent pressure loss. Accuracy can be sustained indefinitely since there are no sharp edges to wear. As you can see in the diagram of the slide, the main part of flow nozzle arrangement used to measure flow rate are first, a flow nozzle which is held between the flank of pipe carrying the fluid that the flow rate is being measured. The throat of flow nozzle area is the minimum. The second one is there is two open plates that call 1 and 2 for attaching a different pressure sensor in both points.
So I'm the second presenter, and I'm going to continue the presentation. My name is Nurlina binti Azmi, and my metric number is AB19294. Operation of flow nozzle. First is the fluid that the flow rate need to be measured enter the nozzle to the section called throat where the area is minimum. Second is before the fluid enter the nozzle, the pressure in the pipe called P1. As the fluid enter the nozzle, The fluid converge due to this pressure keep on reducing until it reach the minimum cross-section area called throat, and the pressure is at the minimum when the fluid reach P2. And the throat of the nozzle is maintained in the fluid for a small length after being discharged in the downstream also. Third is, there is differential pressure sensor attached between point 1 and point 2 to record the pressure difference between these 2 points. Advantages of flow nozzle. First is, installation is easy and is cheaper when compared to ventrimeter. Second is, it is very compact. And the last one is, has high coefficient of discharge.
Hi and Assalamualaikum. My name is Nurul Nashafika binti Sulaiman. My metric number is AB19253. Next, I will continue with disadvantage of flow nozzle. The first disadvantage of flow nozzle is it has low pressure when it's recovery. Second, it has high maintenance. Third is when we install the flow nozzle compared to Ori 5, it's quite difficult. Next, I will talk about the application of flow nozzle. The first application of flow nozzle can be used in a variety of applications where extreme of pressure, temperature, and aggressive to the fluid. Next, flow nozzle often used as the differential pressure device to measure the flow of the fluid. It also can be used to measure flow rate of liquid that discharge to atmosphere. The flow nozzle also can be used in situations where suspended solid has the property of settling. Next, other than that, in this case, flow nozzle is placed in a pipe carrying hose rate of flow.
Assalamualaikum and hi to everyone. My name is Nusra Zahira binti Abdul Razak. My ID number is AB19178. First of all, I want to talk about types of flow nozzles. In this slide, we want to talk about 3 types of flow nozzle, which is flange flow nozzle, flange flow nozzle with integral low pressure taps, and weld-in flow nozzle. Firstly, we will explain about flange flow nozzle. Flange flow nozzle was built with a mounting flange in line with the contour upstream face. The mounting flange is the one that between the end user's pipe flange for hold and seal the flow nozzle inside of the process piping. It also can be provided with a raised gasket face or RTJ groove. The flange flow nozzle has a precision machine shoulder to help assure its concentricity with the adjacent pipe. It is installed between pipe flange when the end user is giving the taps for the upstream and downstream pressure sensation. The flow contour is machined to ASME or ISO specification, and a shoulder is provided on the downstream side of the mounting flange to center the nozzle within the required tolerance. Secondly, we will talk about the flange flow nozzle with integral low pressure taps. It's a little bit different from the first type because the flange flow nozzle with integral low pressure taps is built with the downstream tap integral to the nozzle mounting flange. This design provides the same as ASME or ISO flow contour. It can be used in smaller pipe size where the low pressure tap may interfere with the pipe weld, flange or bolting or flange bolting. The low pressure connection most used is 6 mm unless they give specified otherwise. The third type is well-in flow nozzle. Well-in flow nozzle will be used when the pipe flange cannot be installed because of high pressure or high temperature application, such as in power plant installation. The flow nozzle is designed with a small mounting flange that fit between bevel ends of the inlet and outlet pipe section. The pipe section are welded together with the nozzle. The weld-in flow nozzle also can be provided as a special mounting ring flow nozzle that used to eliminate the need for welding dissimilar metals in the field. Other than that, pipe wall pressure taps are used with this nozzle design, and that it is available in complete flow metering section. For special application or for the smaller line size, well-in flow nozzle with integral metering taps are provided. These flow nozzles design may include a short section of upstream and downstream pipe with flange, bevel or socket weld ends.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Aisyah binti NOZZLE. My metric number is AB19279. So now, I will continue my part, which is methodology. Reynolds number was first demonstrated by Osborne Reynolds. He demonstrated that lamina and turbulent can be predicted. Calculation of the Reynolds numbers helps to determine if the flow in the pipe is laminar flow or turbulent flow. Fluids with a high viscosity flow more slowly and generally not produce eddy currents. Thus, the internal roughness of the pipe has little or no effect on the frictional resistance to flow in the pipe. So, this equation can be basic definition for Reynolds number. Using this formula, we know that if the Reynolds number is less than 2000, the flow will be laminar. And if the Reynolds number is more than 4000, the flow will be turbulent. And if the Reynolds number between 2000 and 4000, it will be transitional. So now, I want to talk about Bernoulli equation. Bernoulli equation was discovered by Daniel Bernoulli. Bernoulli equation relates to the pressure, height, and speed. So, the equation at the slide is Bernoulli equation that is usually written. Next, Bernoulli equation, also known as conservation of energy law for flowing fluids. It is because if there is no added energy to the fluid, the total energy of kinetic energy, potential energy, and flow energy. This equation about total only for incompressible fluids because the specific weight assumed to be same. The equation also states that the total energy in the fluid is constant because there will be no added energy or removed energy from the system. So there will be no heat transfer and energy loss due to friction. We use Darcy equation to find head loss. This equation is named after Henry Darcy and Julius Weisbach. Head loss is caused by the velocity of the flowing water and the roughness of the pipe, channel, walls, or fitting. The equation of Darcy equation is like this.
Next, we will talk about the calculation. So the questions for calculation is about water is flowing through a venturimeter whose inside diameter is 12 cm at the entrance part and 6 cm at the throat with length of 15 meter pipe. The pressure is measured to be 650 kilopascal at the entrance and 270 kilopascal at the throat, and the dynamic viscosity of this fluid is measured by 2.1156 times 10 power of negative 3. Neglecting frictional effects, determine the flow rate of water. First of all, we need to list down the value that we can find in the question. First of all, the diameter. The first diameter is 12 cm, which is 0.12 meter. The second diameter is 6 cm, which is 0.06 meter. The first pressure is 650 kilopascal and the second pressure is 270 kilopascal. The dynamic viscosity of the water is 2.1156 times 0 power of negative 3. The length of the pipe is. First of all, if we want to solve this problem, we need to find the volume of flow rate. If we want to find the final equation to find the volume of flow rate, we need to use two equations, which is Bernoulli equation and equation of volume of flow rate across venturimeter. So if we substitute between these two equations, we will get the final equation that we can solve for volume of flow rate. We will get V equals to area 2 times pressure 1 minus pressure 2 divided by rho times 1 minus area 2 over or area 1. So if we put in the value in the equation, we will get A2, area 2 times 2 times 650 minus 270 divided by 1000 times 1 minus 0.064 over 0.124 square root. So the final answer that we will get to find the volume of flow rate, we will get 0.07795 meter cube per second. Next, we need to find the Reynolds number. We need to find the Reynolds number so that we will know the types of flow inside the pipe. Reynolds equation is rho times volume of flow rates times diameters divided by dynamic viscosity of this fluid. So if we put the value in the equation, we will get 1000 times 0.07795 times 0.06 divided by 2.1156 times 10 power of negative 3. So the final answer that we will get is 2210.720. So the flow in this pipe is transitional because the value of Reynolds number more than 2000 but less than 4000. So the next, we need to calculate the head loss at entrance. So using the head loss equation, we will find FD times L over D times V squared over 2G. So if we put in the value in this equation, we will get head loss equals to 64 times 2210.720 times 15 over 12 times 0.07795 square divided by 2 times 9.81 for gravity. So the final answer, we will get 54.7718 meter. So next, we need to find head loss at throat. We use the same equation as entrance for head loss. we use equation head loss equals to FD times L over D times V square over 2G. So we put the value in and we will get 64 times 2210.720 times 15 over 6 times 0.07795 square over 2 times 9.81. So the final answer we will get is 109.5437 meter. So finally we need to calculate the total of head loss, which is head loss at entrance plus head loss at throat.
For calculate the rate of flow of water, we use Bernoulli equation to find out the velocity, and the velocity that we got is 0.07795 meter cube per second. After that, we calculate the Reynolds number, and the result shows that the flow is transitional because the Reynolds number that we got is smaller than 4000. Therefore, the flow is transitional, and then we calculate the head loss at entrance and throat. So the calculation for the head loss at entrance is equal to 54.7718 meter, while the head loss at throat is equal to 109.5437 meter. So the total of head loss is 194.3155 meter. Flow pattern in a fluid, either it's a gas or liquid, is depend on three factors, which is the characteristic of the fluid, second is the speed of the flow, and the last one is the shape of the solid surface. So the first one is the characteristic of the fluid. Three characteristics of the fluid are of special importance is density, viscosity, and compressibility. Viscosity is the amount of internal friction or resistance to flow. Water, for instance, is less viscous than the honey, which explains why the water flows more easily than the honey. We also got how to reduce energy loss due to the friction. So the first one is reduce interior surface roughness of the piping system. Second is increase the pipe diameter of the piping system. And the third one is minimize the length of the piping system. Minimize the number of elbows, teeth, valve, fitting and other obstruction in the piping system. And replace it to 90 degrees turns with a gentle bend. A nozzle is a device designed to control the direction or characteristic of the fluid flow, especially to increase the velocity as it exits or enters enclosed chamber or pipe. A nozzle is often a pipe or a tube of varying cross-sectional area, and it can be used to direct or modify the flow of the fluid, either it's a gas or liquid. Nozzles are frequently used to control the rate of flow, speed, direction, mass, shape, and the pressure of the stream that emerge from them. In a nozzle, the velocity of the fluid increases at the expenses of its pressure energy.
I'm presented 3 before, and I will continue with conclusion of this presentation. Here are our group conclusion. Fluid is a quantity of a gas or liquid moving through a pipe which is passes a unit per time, usually represented by symbol Q. Next, based on our calculation, we use flow meter to measure the flow rate. This measuring technique, operation and characteristic are determined by comparing pressure drop and related to the velocity of the fluid in the pipe. We using a Bernoulli equation to calculate this equation and continue to equation. The pressure drop measured using a differential sensor, and when it's calibrated, it's become a measure flow rate. That's all from us. Thank you for watching.